All right, hello everyone. This is Daniel. We're back for another edition of The Binding Status. We're going to be doing a kind of cool format today where we're going to have Hasan and Javad join me on this. We're going to do that by live streaming a Zoom call. So it might get a little bit hairy, but if you have any problems with sound, or the format, or you're not able to see things, or it's lagging, please feel free to drop comments in the live chat. And you can also join us on Crossplane Slack and join the TBS channel where we can have some live discussion during the show. And so just to jump into the comments, it looks like Marcus is on. Marcus is a faithful viewer and a previous host of The Binding Status. So thanks for joining from New Jersey, Marcus. Jared appears to also be on. Phil as well. So I think Phil is in Seattle. So it's good to have all of you here. Like they've done, please feel free to introduce yourself in the chat. And I'll try to look at that regularly so we can go through that. But today, this show is basically just going to be looking at the newest release of Crossplane 0.4 and kind of going through the release notes, seeing what's there, and then doing some demos to actually look at how that works practically. And like I said, Javad and Hasan are going to be joining me on this show, which should be really cool because they contributed some really key parts to this release. So I'm really excited to have them on the show. Before I get started, per usual, I want to give a shout out to the Utah Jazz who got a big win over the 76ers last night. So that was good to see. Try and make it a little bit personable for y'all. Alright, so let's go ahead and jump into it. Let me get over here to our streaming format. Alright, so here we're looking at the Crossplane repo, and I will jump over to the release. So as you can see, we've actually had a patch release since then that fixed some Helm install stuff that Hasan also worked on here. But we're going to be focusing in on the 0.4 release here. Also quickly, it looks like we have Enrique joining from, I'm not sure how to pronounce that. I think I've seen this before, so it's probably just my own ignorance, but The Hague maybe. So thank you for joining, Enrique. And so looking at 0.4 here, we've got some major themes and some notable features, so I'll go through those quickly. So one of the biggest things is that we've just updated the APIs for a couple of our managed resources. So you can see here, these for GCP and AWS were moved to v1 beta 1. So that just means that they are more reflective of how the actual cloud provider API works, which is what we want. We want the closest reflection possible to the API that's exposed by the cloud provider. So those have been updated. The controllers have been refined to use our shared managed reconcilers, which is nice because we have consistency across stacks about how they're performing their reconciliation logic in terms of the format of the actual controller, the code, and then they're obviously customized to interact with that specific cloud provider service. But these v1 beta 1 resources are much better and a big improvement. Muvafik did a lot of work on that, so shout out to him. Cross-resource references, we're going to definitely get into this today. Javad drove this, so these are implemented across AWS, Azure, and GCP, and essentially this just allows you to reference one resource from another so that you can get deterministic names after their provision on a cloud provider. So for instance, if you create a VPC network, which we're going to be doing later, and then you need something that's provisioned into that VPC network and you want to get the name, you can just reference that Kubernetes object, that Crossplane resource, and have it resolved to the name of the network. So we're going to get into that a little bit later, and Javad's going to come on and tell us about that. We also updated our scheduling model to be a lot more simple. And so now, instead of having portable class kind of concepts, we're going to be just going directly from claims to manage resource classes. And it kind of removes a layer there, which looks a lot more simple, and we do label-based scheduling for that, which I'll be getting into a little bit later as well. Crossplane CLI trace functionality, this is what Hasan's going to talk about, so I'm going to leave most of that to him. And then we also introduced Stack Rook, which I've given an early preview on previous episodes, so feel free to check that out. It provides some really cool functionality as well. So like I said, Javad and Hasan are going to be joining me on this episode. I'm going to be doing kind of a demo that encompasses a lot of what they're going to talk about, and it does take some time for all the resources to provision, so I'm going to go ahead and get started with that, and then I'll drop a Zoom link to them, and we'll bring them into this call. So to show kind of this cross-resource reference model, and the way that we can provision resources and then reference them, I'm going to be using a GitOps workflow. So essentially, what we're doing is pointing at a repository which has infrastructure configuration with Crossplane resources in it, and I've actually put these in the TBS repo. So if you'd like to follow along, you can do this exact same setup as me. And let me also open a terminal window here real quickly so that I can show you exactly what's happening. So you're probably familiar with, if you've seen the other episodes, the concept of a crossplane kind of control cluster. So that's where the crossplane binaries are running and the stacks are installed and that sort of thing. So this is where you provision resources from. So you have your control Kubernetes cluster, which then provisions resources, potentially other Kubernetes clusters as well, which we're going to show today. So to get this set up, I have installed Crossplane and Stack GCP into a Kubernetes cluster, and I've also got an Argo CD up and running. So if you're not familiar with Argo CD, it's a really cool project for doing continuous deployment with Kubernetes. This is what the console looks like. I'm actually just port forwarding the Argo service to my local, so that's how I'm able to interact with this. If you want to learn more about how to actually deploy this, you can go over here and they have a really simple quick start. It shows you how to get started. I'm not going to go through all of that. We're actually going to have a guide coming up on the Crossplane website pretty soon that shows how to get this set up and install Crossplane and then do what we're essentially going to do here. But hopping back over to the TBS repo, we can take a quick look in the episodes here. And in the assets, I have this app and infra folder. So in infra, we basically have infrastructure components. So what these are is a network and a subnetwork. I'm not going to get too into these because I think Javad's going to want to touch on these. And then a customization file that defines the resources. And then the app, it would be the application component. So this is deploying WordPress and is once again has some customization file there for declaring these resources. So I'm intentionally being vague so that Javad and Hasan can cover a lot of what we're going to talk about. But I am going to go ahead and get this started and point out a few things that I'll touch on again later on. So we're going to create two applications here. The first we'll call WordPress Infra, and we'll do it in the default project, which just has basically the most permissive permissions, the most permissive RBAC. We're going to set automatic, which means it's going to watch for pushes to the Git repo. And it's really easy how you can do this. So you could do the same setup and actually point it to this public repo as well and deploy the same exact thing we're going to. But in episodes 5, assets infra, that's what we were just looking at. And we're going to do it in cluster. So once again, this is the Crossplane control cluster that has the Crossplane binary running, Stack GCP, as well as Argo. And we'll just do Crossplane system for the namespace here. You could choose any. These are all going to be actually cluster scoped resources. We don't need to do any name prefix. So what this is going to do is provide a really nice visualization of all the things we've created here. And what I want to do quickly is, the network is the main thing that we're provisioning, and it's going to take a minute to come up so we can see all of our configuration here. But quickly, if we caught it in time, you're going to see this right here. So reference to a TBS network, the reference resources do not yet exist, and you'll see in the network ref as opposed to network name. Well, actually, we've already resolved the name, it looks like now. You can actually see it just resolved in real time. So basically, it referenced the TBS network object, and then it pulled the network from that object and applied it here, and then it's using that to provision the resource. So all of these are going to be coming up as we speak, and they'll be over here in our GCP console. And once they're all resolved, so the connection is probably the last thing it's going to resolve. So you can see it is being created. So in short time, it'll probably come available. Basically what these are is a network, subnetwork, and then the global address and connection allows connectivity between a database and our cluster that we're going to provision. And we also have standard cluster, which you may be familiar with as a class, which is basically just configuration details. Once again, referencing that network. And we also have standard MySQL, which is configuration details for creating a Cloud SQL instance. So one last thing before we hop over to having Javad and Hasan on is I will go ahead and deploy the app component. Once again, similar configuration, same repo. Traditionally, you'd probably have an infrastructure repo where you define a lot of your classes and what's available in the universe, and then application repos that have claims in them. These are both in the TBS repo just for convenience here. But we'll point that to the app directory, and we'll do it in cluster. And these are actually going to be namespaced resources, so we're just going to put them in the default namespace. There isn't any subdirectories here, but we'll check that as well. So when we create this, you're going to see that we have these three resources that were in the repo. You'll also see that it shows resources that are created with owner references. So we have this Kubernetes application in our repo over here. And the reconciler for the Kubernetes application is creating Kubernetes application resources from these resource templates. So it's really nice, something like Argo CD can show those references. We also are going to have a command line tool that you'll see shortly that does similar types of things. But these are going to take some time to come up. You'll see that the GKE cluster has bound to that class, and it's waiting for it to come available. Same with the database. These application resources will be waiting for the secret to come available. So we should see, if we look at this, right, it can't get the secret yet because the cluster we're creating to provision this application into has not been created yet. So once that comes available, these will be reconciled, and we're going to come back and revisit this later on. So with that, I think that we should bring in Javad and Hasan here. So let me pull up Slack with them over on the side. Looks like Michael joined as well. Good to see you, Michael. All right. So once again, you may have to bear with us as we kind of figure out how we're going to do this Zoom here. We did a rehearsal yesterday and it went well, so hopefully that works again. What I'm going to do quickly before joining is switch the screen over to just being my screen so that you don't have my face in here twice. Alright, so I've enabled desktop audio as well, so once we join here shortly, we should be able to hear Javad and Hasan. So I'm just opening this up right now. It looks like Javad is here, and as is Hasan. And I'm going to move this over. All right. Javad, Hasan, it looks like y'all are on. Can you hear me okay? Yes, I can. Let me also check to make sure that the audio is coming through on the stream as well. Can you each say something real quick? All right, so it appears.
Not sure if people on YouTube streaming are hearing me.
Yeah, it doesn't look like it's coming through yet, so hopefully I can resolve this real quickly. All right.
Just keep saying random stuff. You're doing awesome. That's a great streaming.
All right, so it's still not coming through. It doesn't look like. Let me see if I can. Oh wait. Let's see here. If this works.
Hey Marcus, can you hear me? Oh, looks like they're hearing me, so it's good.
Oh, they are able to hear you now?
Oh yeah, looks like it.
Awesome. Alright, cool. Okay, bump the volume for Javad I'm seeing here. Real quickly, let me see if I can move that up. Interesting that it's not showing up in the desktop audio in OBS for me. It's also not allowing me to do video here, which I am guessing has to do with the fact that OBS is taking it in. So, although it did work for us yesterday, but regardless, we can go ahead and get started here.
I share my screen. Can you see my screen?
Yeah, it looks good to me.
Okay. Just let me know whenever you're ready.
Yeah, for sure. I think you can go ahead.
Cool. All right. So, hi everyone. My name is Javad. Glad to be here. Been working on Crossplane project, and then from Seattle headquarters. Right now, I'm streaming from Seattle headquarters for Upbound and Crossplane project. Like Dan mentioned, we released very exciting stuff the last 2 weeks, and then one of the things that I was hoping to do a demo for you was this feature we call it cross-referencing. So I'm going to go through a quick sort of presentation what the problem was, how we solved it, and then hopefully do a very short demo as well. So one of the things that Crossplane does, it goes through creating managed resources, which have a mirror and external resource. And then these external resources could be used cluster for a database experience. One of the main things that happens here is we want to be able to create a network configuration for these components like Kubernetes or database so that they could have secure connectivity. This means different things in different providers. In AWS, for example, you have to have VPC, subnets, IAM roles, and then route tables and all those that. I'm not going to go through those details. And then so it's a lot of different components. So you have to create those components and then make it ready for your actual components that you want to tie to each other, like Kubernetes and database. For that to happen, previously what we did was we sort of like had to manually set up those VPCs and softness to talk to each other. So you end up having a VPC ID, then you can like provide that to your like a EPS cluster or database, and then because of those setups, now EPS cluster could talk to the database. But then what we wanted to do, we wanted to make this automated. Can we do this in a GitOps model so that you don't actually have to manually create anything? Um, so the answer to that question was like mixed. Partially yes. So what we did initially, we kind of like created corresponding managed resources for all these types. So for VPC, for example, we had a managed resource inside Crossplane, which would copy that. And also the same thing for other components. However, we had the problem that we still needed some manual intervention. This manual intervention were because of two problems that we had. One was that a lot of these sort of like managed resources that we have to create were consuming some attributes which were indeterministic. For example, so you're creating a VPC and then you want to create a subnet, but that subnet itself requires a VPC ID, but you don't know what VPC ID is until you create a VPC. And then because of this, it wouldn't be possible for you to like create a GitOps model, a folder of YAML files, and then submit it and be done with it. The other problem was the order of the components. So you have to create a VPC first, and then create the subnet after that, if you want to kind of like relate to the first problem. You want to wait that for that application to run. I'm going to show you a quick sort of like a graph that they have. So if you look at this graph, for example, so we're having a VPC component, and then this VPC component is being referenced by different subnets, a internet gateway, and then all the other different components which are required for us to make this secure connectivity in AWS possible. So the solution that we had was we wanted to make the Crossplane itself smart enough so that it kind of like figures out the dependencies. So you could submit the YAML file for all these components at once, and then Crossplane is smart enough to just figure it out. So for example, if it wants to create subnet ID, it waits for VPC to be created, and after that, it kind of like resolves that VPC ID in this component and creates. So first thing was blind provisioning until the dependent resource is ready. We also wanted to be able to, so when you're presenting this VPC in a YAML file that has a name which is only meaningful for that YAML folder. So we wanted to be able to reference that YAML name so you know that, hey, I want to get the VPC ID from this YAML object. The other thing that we wanted to do was we wanted to, after that, to continue normal with installation as we have before. So to do this, I just want to talk a little bit about technical implementation, how we did this. I will open up the design document that we have for this, and you can read that for yourself if you want to. But I wanted to kind of like go through the goals that we had for why we chose this specific technical implementation.
Hey, Javad.
Yeah.
I'm going to try and switch the sound here. It seems like they're still having some trouble here, and I'm thinking it might be coming through my actual my headset, like your audio coming through my headset. So I'm going to try and change this here and see if that'll fix it here.
Can you hear me now?
All right, so I'm thinking now that I've just switched it over to the desktop audio, and I think that should fix it. Will you try and say a few things?
Sure. Can you hear me, you guys, in YouTube streaming? Hello?
Let's see. It's appearing as such in OBS for me, and so I'm thinking it's happening. Let me correct one more thing here. All right, so it looks like it is fixed. So feel free to go ahead.
Awesome. All right. Yeah. So I was going through the goals that we had for technical implementations and the specific design that we chose. The goals were that these are a little bit technical. So Just bear with me. I'm going to go through the demo later, but for folks who are interested. So we wanted to minimize the cross-cutting impact on existing design. We don't want to introduce this referencing in a way that it completely changes all the designs that we have. We wanted to make this as minimize the impact as possible. The other goals that we had, we wanted to keep the flexibility of resolving references as high as possible, so that if you, for example, wanted to resolve a VPC ID from a VPC object, we know what to do there. But then if there is something more sophisticated to create an attribute, we wanted to be able to make it flexible enough to do that. We also had in mind that we want to keep the code readability high. So we wanted to explicitly say, hey, this specific field is for cross-referencing. We wanted to make sure that it's highly debuggable, so that if you see something's not running, you could easily see, debug it and see what's going on. The other goal that we had was we wanted to keep high fidelity of external resources still the same. So if someone doesn't want to use these references and actually want to use actual VPC instead of VPC dereference, they should be able to do that still. The technology that we use reflection. Using reflection, it reduces the glue code for each managed resource to some extent, and also it enforces a central validation and the reconciliation process that is going to be very handy for us. So I'm going to switch over to the doc that we have for cross-resource referencing, and very, very briefly just go through what the technical implementation were. So for cross-resource references, we basically introduced this interface, attribute referencer. And then for each attribute that you want to be referenced, you need to implement all of these: get a status, build, and assign. And then now in the presentation of the file itself, we introduce this VPC ID ref, if you're talking about VPC ID. And then we add this attribute as this resources attribute referencer. And then this makes the reconciliation automatically determine, hey, this is a referencer, so it needs to go through first it needs to match through this interface, and then after that it needs to run these different methods from that interface in order to resolve those references. And then the impact in the API is that now you see that we have introduced this VPC ID ref instead of VPC ID, which points to the actual object of the VPC that we have. And again, you can read this document. It's cross-resource references in design folder in Crossplane. So yeah. I'm gonna increase my font size. I think so I'm gonna go back to here and then increase the font size. So now the next thing I wanted to show a demo. What I have here, so we have an example folder in Crossplane repository for workloads for WordPress and then for AWS. Like Dan mentioned, the network configurations or infrastructure that we call it is part of that setup. I'm going to go ahead and create this network configurations and show how. So if you look at this folder, we have a VPC object, and then we have a subnet object, which is referencing this VPC references in it. So we have 3 objects, and then each of these are having VPC ID ref, which is basically pointing to these objects that we have here. So I have already set up Crossplane and also AWS Stack. What I'm gonna do, are you guys seeing this okay? Is this visible enough? See if I could a little bit increase this. Okay. So if I do keep control, get nodes, I should be able to see that the kind control local cluster kind, which is Crossplane installed in it, is there, and also I have installed AWS Stack on it. All I need to do, I need to keep control. All I need to do, I need to keep control apply. The Kubernetes folders that they have, customized folder they have, which is network config. And then it just basically goes ahead and creates all those objects for you. And this is going to be a GitOps model. So if you enter this, you're going to see that all of these are created. And then if you want to see what happened, you can basically get those resources and then see that all of those are actually created. So if you look at this, this is a little bit hard to read, but basically different components that were created, all of them are now in the state of ready. And then, so so the other command I'm going to run is going to be, just give me 1 second. I'm going to use this JSON pass command in it, so it shows what's the status of references resolve the status there. So it shows that all these components that we created, the references resolve a status for them are true. So yeah, so it shows like after a few seconds, without doing any manual intervention, everything is created, and then all of those cross-resource references are read and then applied. So one thing that I also wanted to show, I'm just gonna go and delete this thing that I created. So it starts deleting all of those things. What I'm gonna do, I'm gonna actually remove that VPC from customization. Remember, in this dependency graph, we can see that a lot of these components are dependent on this VPC. So if we remove this VPC for a bit, then it should kind of like block other resources from being created. So let's just do that. So I'm just going to comment this out, and then I'm going to go ahead. Let's wait for this to be deleted. Looks like it still is reconciliating. Okay, so it shows that all of them are created again. Now, what I want to see the JSON path of all of those. As you can see, because we have removed this VPC, all the other components are still waiting for it. So this reference resolve status of these resources that we created in this folder are false because they're waiting for the VPC to be created. Now, if we uncomment this and then apply it again, we should be able to see that eventually all of them are becoming true as the VPC is created. There seems to be a reconciliation problem here, but I just wanted to show you that it is smart enough to kind of like go ahead and like figure out the dependency and be blocked by it. I think this is the kind of like a demo that I wanted to show. If there's any questions or anything you wanted me to add, Dan, please let me know.
Cool. That was really awesome, Javad. I appreciate you showing that, and also just all the work you did on that to get that implemented. It's like a huge part of moving forward with Crossplane, so your work was super valuable there. And at the end of this, I'll kind of show the end result of what that looks like. I'll get back in Argo and we can see the WordPress instance come up and whatnot. So thanks for doing that, and also thanks for joining the call. Feel free to stay on if you like. I'm going to pass it off to Hasan now, who's going to talk about the CLI trace command.
Thank you.
Okay, so can you hear me?
Yep, sounds good.
Okay, great. So I will share my screen, and okay, I hope you can see my screen right now. Okay, so this is Hasan. I recently joined to Crossplane team in about 1 month ago, and the trace utility is one of the first features that I have worked on. And I will quickly make an overview of this utility, and then I will talk about how it works in short, and then I'm planning to make a short demo how this tool can be useful and can provide some value. Okay, so let me start with the overview. So the trace utility is part of existing Crossplane CLI, which is distributed as a kubectl plugin. And this provides a holistic view of Crossplane resources, showing the relationship between them and basically collecting all the related resources together and providing an overview of what's going on the cluster. So normally, without this tool, there are some when you deploy a Kubernetes, when you deploy a Crossplane resource, and the next one go on. So goes on. There are relationships between the Crossplane object, like the Kubernetes pattern of, for persistent volume claims and persistent volumes and the storage classes. So this results in different related pieces. So, for example, when you deploy a Kubernetes application, which is the kind of topmost resource of for a Crossplane consuming workload, then if you find a failure, you need to first check the next one, which is a Kubernetes application resource. You may need to check the Kubernetes cluster resource, which it depends on, and the Kubernetes cluster resource is actually the claim, which corresponds to persistent volume claim, and it is provided or it is satisfied with a infrastructure Kubernetes cluster like GKE cluster. The next one would be to check this one. But with the trace tool, what you need to do is you need to run kubectl crossplane trace, and then like Kubernetes application, the name of the application and namespace, and this tool will provide some kind of an overview and collect all the related information for you. So this tool also introduces some kind of state to make a quick overview of the overall status. And this state could be ready, not ready, or missing. And this state is represented with some check marks or exclamation mark or the cross sign. So this is kind of an example output, but what you will see when you run the trace tool for a Kubernetes application. As you can see, for a Kubernetes application, has a relationship between a couple of resources like Kubernetes cluster, MySQL instance, a couple of application resources, GKE clusters, Cloud SQL instances. This is actually the output of our sample WordPress stack, and some providers, secrets, etc. But this tool collects all the information together, and you can see that, for example, the Kubernetes application is not ready. The MySQL instance become ready, and it is bound. However, the GKE cluster is not ready yet. And also, if you scroll up, you can see some status information, like the GKE cluster is not ready because it is provisioning state, and so on. So this is the text output. This tool can also provide a graph output. Actually, it will not draw the graph itself, rather it will provide a dot definition, which can be visualized by GraphViz. And with this graph output, you can the relationship objects and their status. If it is black and so this means this resource. If it is in red, this means that this resource is not, this resource is missing, and the yellow or orange ones means this is still in progress. So I will show, I will make a quick demo, and we will see how it works again. the output again. But before that, before jumping to the demo, I want to quickly talk about how it works. So basically, the Crossplane resources can be categorized in 6 different categories here, or at least the tool currently supports these categories. And any Crossplane resource will be categorized in one of these categories, and then the next object or the related objects will be found with the fields mentioned here. Like if you deploy the Kubernetes application, it has a relationship between the Kubernetes cluster, which is referenced at status.clusterref, or this Kubernetes application has some dependencies on some Kubernetes application resources or some resource claims, and these could be found by filtering with the labels located at spec.resourceselectors.match labels, and so on. So this is how the tool currently is working. And we also have some feature work. Jawad has just mentioned the work that he has done in this release, which is the depending, which is resource reference, cross-resource referencing. So this tool currently does not support finding the related resources or related network resources for a given Crossplane resource. So this is one of the things that needs to be added. Another thing is currently all these relations and types or groups are embedded into the code. So one cool feature that we are thinking is supporting dynamically defining new resources via some kind of a config file, and without rebuilding the whole binary, we can add new types and introduce new types, which could position or which could make the tool as a general purpose tracing tool for tracing any Kubernetes resource. So this is kind of a common need, even in Kubernetes deployment. For example, you may need to find the pods deployed with the Kubernetes, and this you can use this tool for this purpose. This course has not such a value, but any custom resources, any created custom resources for any other project usually have some dependencies between other custom resources. So these tools could be used for them as well. So these are the major feature works that we are planning to do. So I will make a quick demo, as I said. So currently, I don't have any Kubernetes application deployed in my namespace, and now I will create a WordPress instance in this namespace, and then try to trace the Kubernetes application just created in this namespace. So kubectl crossplane trace Kubernetes application, and then I give the name of the Kubernetes application and namespace, and it collects information, and here is the current status or overview. So as you can see, the GCP account credentials providers are ready right now. There is no issue with that, and we have the classes, instance classes or EKS cluster class, and we want to reach to a state where we see all of the resources deployed. So I think I forgot something. For example, I just found an issue. Actually, I forgot to create the EKS cluster class, which means that if it is missing, the cluster will not be created. So this is one thing that needs to be fixed here. But since this would take some time, I also want to show how it will look like at the end if everything goes well. So this is a recording that I made some time ago. So for example, for a deployment, after you've made some long enough, you will see that all the states of all resources are ready. And also we can see the IP address of the WordPress available here. Yeah, we talk about. If there are any questions, I can respond.
Hasan, did you mean for your screen to go away? It doesn't look like your audio is coming through either.
Okay. Can you see it now?
Yep, looks good.
Okay. Actually, I'm done with my demo and presentation. So if there are any questions, I can reply. Let me also stop sharing.
Cool. Thanks so much, Hasan. That was really awesome. And I appreciate both you and Javad joining. To finish out, I am going to go ahead and end this call. Well, it looks like y'all jumped off anyway, so perfect. All right. Let me quickly jump back over to my stream setup here. Alright, so we're back on the stream setup here, and I'm just going to go through the last bits of what we were looking at earlier. Let me look back over at the comments here. It looks like everything is good. I mentioned in the chat here that show notes are updated following episodes in the TBS repo, so please feel free to check those out there. We'll try to keep any relevant issues or things we talk about or blog posts or guides linked in that place. Also provide some timestamps to make it easier to navigate this stream once it's published. But it looks like all of our resources have come up here, so let's quickly look over at the infrastructure. So if you remember correctly, we created a network, a subnetwork. We created classes for both a Cloud SQL MySQL database and a GKE cluster. And then we created a connection and global address, which basically just ensures secure connectivity between the database, which is kind of provisioned in a platform as a service manner, to the GKE cluster, which actually lives in the network that we created. And we can see that actually if we look over at the GKE cluster class that has a reference to the TBS network. So now let's look over at the app. So when we left last time, it was still waiting for these deployments, namespaces, service, these Kubernetes application resources to come available. They weren't able to find a cluster to be scheduled onto because the GKE cluster was in the process of creation. So if you remember, there was a status on the Kubernetes application resources that said it was unable to find the secret. And so now you'll actually see, and this is another beauty of doing this in something with a nice user interface, you'll see that two secrets have been created. One for connection to the SQL database, and one for connection to the GKE cluster. And what we're doing in this demo deployment here is we're scheduling it to the cluster that we created. So if we look over here, you'll actually see that this is labeled with the WordPress demo. And so we will schedule to that. And you can see here that the labels are the same. And then the other thing we're going to do is pull the secret from the database and inject that into the WordPress container so that it's able to talk to the database. So here we have a namespace and deployment, and then how we're going to access that from the outside world is basically just a Kubernetes service. So this application resource is just a template for a Kubernetes service, specifically a load balancer. Once that's provisioned in the target cluster, so once again, we are Argo and Crossplane and Stack GCP are running in a control cluster, and then from that control cluster, we've provisioned another GKE cluster, which we've then deployed WordPress into. Another thing that I mentioned last episode was that we're going to soon support the ability to provision directly in a cluster. So you could provision WordPress in the control cluster, or you could bring your own cluster. So let's say you have an on-prem one, or you just have a GKE or AKS or EKS cluster that you provision not using Crossplane. You can just create connection information in Crossplane to be able to provision resources there. So then you can manage lots of other clusters from one central one, which is really powerful. In the demo that I showed with Rook, you kind of can see where that can happen. There's actually a guide now on the Crossplane docs that show how to do that with Rook. But one of the things that's nice about the Kubernetes application resource for a load balancer is it's going to propagate this IP back to us. So this is the IP in the remote GKE cluster that's been provisioned, the external IP that's been provisioned for this WordPress app that we've deployed. So I'm going to quickly copy that. And if we go over here and paste this in our browser, we'll see that WordPress is now up and you are ready to get started. So that's one of the really powerful things about using these cross-resource references. You can resolve the names after creation, and so you can create a full infrastructure setup. So we basically went from zero to everything you'd need in GCP to be able to provision an application. And so we created the network, we created resources in that network, specifically GKE and Cloud SQL, and then we deployed a application into the GKE cluster we provisioned. So there's all kinds of functionality that's enabled now in a GitOps workflow using these cross-resource references and using the existing features of Crossplane, and doing that in Argo CD just makes it a lot easier. And if you want to make a change, we could just push an update to this repository, and it would automatically sync that with these resources. So let's say we wanted the replicas of the WordPress app to be increased in the deployment. If we just push an update in the repo, then that would automatically happen. If we wanted to move it from one infrastructure setup to another, let's say we had GCP and AWS resources created here, we had classes for each of them, then we could simply change labels to select different resources. And last thing I want to touch on here that is a change in 0.4 from 0.3 was this simple resource class selection. So both of these resources, these claims here, they actually do not use any label selectors to find their resource class. And that is because we have provisioned these resources with the annotation that specifies these as default, and you'll see that right here. So this is something new where you can, when you create a class, if you specify it as default, it will say for any Kubernetes cluster claim in this case, or whatever claim is used to get that resource, to create that resource, that we want this to serve as the default. What you can also do is add labels. So we could put something like Kate's : small or something like that for this GKE cluster class. So if someone wants, a Kate's resource, Kubernetes cluster resource, a small one, then they could put that label on their claim here. So they would just add a label selector, which we have some examples of in our examples folder, appropriately named, and it would select that resource based on the matching labels. So that's an update in Crossplane. It might be something that we want to dive into even deeper next time. If you are specifically interested in how that works, once again, feel free to check out our guides, which use that pretty heavily. They use both the defaulting and the claim selectors. There's also a design doc here, which is really helpful. Simple class selection that Nick worked on, which Nick drives a lot of our design work and is responsible for a lot of the architecture components of how Crossplane resources work kind of internally. This is just a really great design doc here that lays it out very nicely. And you can see here, this would be example of, we used a MySQL instance claim in our example, but if you used a Postgres instance claim, you can match labels to these. And if you just omitted that completely, then it would use the default if one is available. So that was a lot of information kind of packed into one episode. Feel free to go out and check out those release notes on Crossplane. We should have another release coming here pretty soon, leading up to KubeCon. We will be at KubeCon, so if you would like to talk more about Crossplane, learn more about it, see demos, that sort of thing, please feel free to come by and see us there. And another thing, there's also a Multi-Cloud Con, which I believe there's a website up for at this point. So this is a day zero event that's going to be happening, and there's some really awesome speakers here, including GitLab, Upbound, obviously, DigitalOcean, a couple others. So this is going to be a really cool event as well. So we'll be there also. So please feel free to come see us. I'm always happy to talk about it, and I'm sure many of the others, especially those that work on Crossplane directly, feel the same way. We'd love to chat with you. So with that, I am going to wrap up this episode. Thanks for bearing with us while we figured out some of the Zoom difficulties with the audio. But I think it turned out to be pretty cool to have multiple people on here, and we'll continue to refine that in the future. So with that, have a good rest of your Thursday, and come see us on Crossplane Slack. All right.